MongoDB is schemaless. You can store whatever documents you want in whatever collection. However, just because you can store any document doesn't mean that you should. In order to get good performance and developer productivity from MongoDB, you should think carefully about your schema design. The first schema design principle you will learn about is the result of these three MongoDB characteristics. MongoDB can update documents in place very quickly as long as the document size doesn't change too much, and MongoDB is optimized for fast queries on individual documents. However, MongoDB has no notion of joins. There is no way to reliably merge data from different collections like you would with joins in SQL databases. For instance, suppose you have a collection of users and a collection of reviews. Each review tracks which user posted it. In order to get a user and their corresponding reviews, you would have to run two queries, one for the user and one for each of their reviews. There's no way to do this with one query in MongoDB unless you change the schema. Furthermore, there is no way to sort users by their average review score in MongoDB with this schema. You would have to pre-compute the average review score and store it in the user document if you want to sort by it. In order to take advantage of MongoDB's strengths, you should remember that your MongoDB schemas should closely match the data you want to display to the end user. For instance, if you want to display the average review score for a user, you should track the average review score in the user document rather than recomputing it every time you load a user by loading each and every individual review. A helpful mnemonic for remembering this principle is store what you query for. This may seem counterintuitive if you are used to SQL databases, because this is definitely not their normal form. However, storing exactly what you query for is easier to understand, reason about, and debug, because there's less data transformation between the client and the database. It's also better for performance, because reading a single MongoDB document requires fewer different non-sequential hard drive reads than executing an SQL query with multiple joins. In other words, MongoDB's lack of joins may seem intimidating to developers from an SQL background. However, to paraphrase Linux's original architect Linus Torvalds, if you have an API endpoint with multiple joins, you're screwed anyway and should fix your API. As you'll see when you design the API for your retail app, each API endpoint will be primarily responsible for loading data from a single collection.